So now we're going to be looking about derivatives of parametric equations. And so in these problems, they're asked to find the derivative, the equations of the tangent and normal lines at the given points, find where the curve has a horizontal tangent line, and find the second derivative. So these are sort of the common things you'll have to do when you're doing parametric equations to find each of these. So in a parametric equation, remember, we have x and y as a function of some other independent variables. And the simplest way you think of this is dy dx is the derivative with dt. If you think of these as fractions, this will work because the dt's will cancel and you'll get dy over dx. So that's how I remember the formula, at least. And so dy dt in this case is 2t, dx dt is 1, so it's 2t. Okay, so that's A. B, find the equations of the tangent normal lines at the points given. So at t equals 1. So remember, for tangent and normal lines, for any line you need to create, you need a point and you need a slope. Okay, dy dx tells me the slope. So I know the slope of my line is dy dx evaluated at t equals 1. Okay, and so in this case it would be 2 times 1, which is 2. So that's the slope of my, this would be for the tangent line. And for the normal line, the slope would be negative reciprocal, right? That's the normal line. So it'd be negative 1/2. Now the point is just x and y at t equals 1. And so the point is going to be 1 squared, which is just the point 1, 1. And so for the tangent line, we're going to use our point slope form. That's y minus 1 is equal to 2 times quantity x minus 1. And for the normal line, it's the exact same thing, but the slope is different. Y minus 1 is equal to negative 1/2 x minus 1. And those would be enough. Okay? Now you can rearrange it or do it whatever algebra to make it slope intercept form if you want, but this is a perfectly fine form to leave it in, slope point form. Find where the curve has a horizontal tangent line. So horizontal tangent lines are where the dy dx is equal to 0, right? Horizontal tangent line means the slope of the tangent line is 0. And that it's because this is equal to 2t, that happens at t equals 0. And so that happens at the point, in this case, t equals 0. That's at the point 0, 0. Okay. And then second, find the second derivative. Now this one's a little bit trickier because we don't do like the second derivative of this or anything like that. To do the second derivative, you're taking the derivative of this with respect to t. So you're taking the derivative, actually you're taking the derivative of dy dx with respect to x, right? That's ultimately what we're doing. And so when you want to take the derivative of any function with respect to x, you can do the derivative, you're gonna do similar thing to this. You're gonna take the derivative of this whole thing with respect to t, derivative with respect to t of this function dy dx, and divided by the derivative with x with respect to t, like this. Okay, it's kind of like this same notation. When I wanted to do the derivative with this respect to the x, I take the derivative of my function with respect to dt divided by dx dt, and I'm going to do the same thing here. Now dy dx is 2t, and so the derivative of that is 2, and dx dt is 1, so this is just 2. Okay, it's a constant. Okay, and that's because, let's see if this makes sense. This equation, I can do it a different way if you want, without the parametric way. Because of this is y is equal to x squared, if you see, because x squared is t squared, and so y equals x. So this is a parabola, y equals x squared. And what's the second derivative of this? dy dx is equal to 2x, right? And 2x is t, that's the same as 2t in this parameterization, so that's what we got in part A. And then the second derivative is equal to 2, and that's what we found here. Okay, so let's continue. Thanks for watching. If you enjoyed this video, I go through a lot more of these exact kinds of problems with much longer videos on my website. It's entirely free. Check out the link in the description below.